So projectile motion. Projectile motion. So what is projectile? Projectile, it is an object that is in flight after it being thrown or projected is called a projectile, or we can say it is an object which is moving in the air without being propelled by any fuel or an engine. There is no engine, there is no fuel in the body, though it is moving or it is in the flight. So that object is called projectile. The example is the tennis ball, football. When you kick the football, it comes into the motion and it moves through the air from one point to another point. So that is also example of projectile. So projectile is any object which can move, which can take a flight, and it is without engine and fuel. It is not being propelled by any fuel or engine. It is moving under the effect of gravity alone. So that objects are called projectile. There are many more examples of projectile. So the motion of that object is called projectile motion. The motion of a projectile which is in flight after it is being thrown or projected is called projectile motion. So it can be understood as the result of two separate simultaneously occurring components of motion along x-axis and y-axis. When a body moves on the moves along the straight line, it has only one dimension about x-axis, but the body moves in the air. It has some height also with respect to the ground, and from the reference point, it has a height as well as horizontal distance. So vertical distance as well as horizontal distance. Combination of these two displacement or distances is the trajectory of the projectile through the air. So it has two components of motion. So the component along the horizontal direction or x-axis is without acceleration. It is without acceleration. And the component along the vertical direction, that is along the y-axis, is with constant acceleration under the influence of gravity. So vertical motion of the object will be uniformly accelerated, or we can say with constant acceleration, but along the horizontal axis, the acceleration is zero. So it is moving uniformly. That is the reason you must have watched in the movies, the hero is riding on the horse. Suddenly a plank of wood come in the way. He jumped off the horse, and when he landed on the again, the horse was there under him. So that is the same case. Or it is with the same skateboard. You are playing with the skateboard. You are in the motion. You just jump, and when you will come down on the ground, when you will land, the board will be under you, because your component of velocity along the x-axis and of the moving vehicle will be the same. So in our study, the air resistance is negligible and the acceleration due to gravity is constant over the entire path of the projectile. We will assume these conditions. You can take the screenshot. Take the screenshot.
Sir, taken.
Okay. So equation of a projectile motion. So suppose that projectile is launched with velocity, initial velocity v0, that makes an angle theta with the x-axis. So we are taking two axes now to describe the motion of this object. First is x-axis, another is y-axis, and the projectile is thrown. So it will describe this path. It will follow this path. This is called trajectory. So we projected the body here with, we give initial velocity v0, and this velocity is inclined with an angle theta with the horizontal axis. Now acceleration is along the y-axis, means in the opposite direction of y-axis. So acceleration is negative. Acceleration is negative. Or simply we can say, when I told you in the class, when we throw a body in upward direction, means away from the surface of Earth, the acceleration is negative. So acceleration acting on the projectile is due to the gravity which is directed vertically downward, and acceleration is negative g j cap. Negative g j cap. J cap signifies that acceleration is acting along the negative direction of y-axis. Or we can say in this projectile motion, the acceleration is only acting along the y-axis. So if the acceleration acting only along the y-axis, then its component along the other two axes, along x and z axis, that would be 0. So the component of acceleration along x-axis is 0, as well as component of acceleration along y-axis is negative. Along z-axis will also be 0, because we are learning 2D plane, motion in the 2D plane. The third axis has not been included in this representation. So now the component of initial velocity. So when you project the object along this direction, that is making angle theta with the horizontal axis, so it has two components. So first along the x-axis, that is v0 cos theta, any vector which is moving in xy plane. So its component along the x-axis is denoted by cos theta, and the component along the vertical axis or y-axis is denoted by sin theta. So the component v0 along x-axis, v0 cos theta, or along y-axis it is v0 sin theta. So if the initial position is taken as the origin, this is the initial position, origin for the projectile, then at origin both displacements are 0. So x0 means position is 0, y0 is also 0 at the origin. Now therefore we will apply this formula: x is equal to x0 plus v0 xt plus half at square. So, or we can apply simply second equation of motion. So x is equal to v0 xt, that will be equal to v0 cos theta into time, because initial horizontal velocity is taken as, initial position is taken as 0 with respect to the origin, and it is with respect to the y-axis. So we have calculated x component and the y component of the motion. The component of velocity at time t are vx, v suffix x is equal to v naught x plus a suffix x t. It will become, when we put the substitute the value of v naught x, that will be v naught cos theta. And for y-axis, vy is equal to v naught y plus ayt. We will substitute all the component of the y-axis, then it will become vy v naught sin theta minus gt, because the acceleration is negative along the y-axis. You can take the screenshot.
Sir, taken.
Please take the screenshot. Okay. Only Akshad is replying. What about the rest of the class?
Yes, sir.
Taken, sir.
Okay. So, let us consider the motion of the object along this these axes, x and y, along the x and y axis. So these are the velocity components: initial velocity v0 cos theta, v0 sin theta along x and y axis. This is the direction of the acceleration. So as the object moves and it achieves the highest point of its projectile or its motion or its direction with respect to the ground, its velocity decreases because of the acceleration, which is negative. So at any point, velocity has two components. V naught cos theta means horizontal component of the velocity remains the same. So it was same at the projection, at this point, and at this point. But as the body approaches or attains or achieves the highest point or the maximum height, its vertical component decreases as at every point as the body advances towards the peak point. Its vertical component becomes zero at the maximum height. Then the body changes its direction and it starts to move in the direction of the earth. Then again, its vertical component starts to increase. So in the first half of the motion, the velocity component along the y-axis decreases. In the next half of its motion, from the maximum height up to the ground, the vertical velocity component begins to increase again. And this is the velocity with which the body strikes with the ground. So it is the velocity at any time. Just take the screenshot. We will do it on the whiteboard also. Okay. So now I'm using the whiteboard.